Hello and welcome to Math with Mrs. Becker. Today in Pre-Calculus, we are going to work through section 4.5, where we will focus on complex numbers. We have equations, and here's some examples. X squared equals a -1 and x squared equals a -4. When you go to solve these particular equations, you have no real solutions. What that means is that we have imaginary solutions. And the reason why is because you can never have a negative underneath a square root. So let's say I have x squared equals -1, and I want to go ahead and solve. To cancel a power of 2, you take the square root of each side. This would cancel this, so x would equal. Remember, when you cancel a power of 2, you need to include both a positive and negative. But if I go into my calculator and I try to enter the square root of a -1, I get a domain error. That's because you cannot have a negative underneath the radical. So this has no real solution. So what happened is an imaginary unit was identified, okay? And what that means is anytime you have the square root of a -1, by definition, that's an imaginary number. So you can replace the square root of a -1 with I. So here's an example, something that we looked at back in Algebra 2. So let's say I have the square root of -25. Okay, this is not real. So what you're allowed to do is take out the -1, then my square root is now a positive 25. Now I can simplify. The square root of -1 means that this thing is imaginary. The square root of 25 is 5. This is a product, so I multiply this. I times 5 would be 5i. Okay, let's do one more just to make sure. If I have the square root of -49, you cannot have a negative underneath the radical. So what you do, by definition, you can take out a square root of -1, because if I pull the negative out, now the 49 is positive. The square root of a -1 is I. The square root of 49 is 7. This is a product. That means you multiply those. I times 7 would be 7i. Okay, so we are moving forward to where all of our solutions will no longer be real. We might have some real, some imaginary, some complex, which is what we're going to go ahead and keep talking about. Okay, so things that you need to know. The square root of a -1 is I. If you ever have I squared, so like if you take I times I, you would get I squared, that can be replaced with the real number -1. Every complex number means that it contains both a real number and an imaginary number. So here are examples of complex numbers. You write them in the form a plus bi. And what's important here is that you realize the real number, the value that does not contain I, comes first. The imaginary number comes second. So here, 2 minus 6i. Notice the imaginary term was second. 0 plus 5i. -3 minus I. 2 plus 5i. 3 plus 0i. -7 minus 6i. Those are all examples of complex numbers. You have a real number, then either plus or minus, then an imaginary number. One way that we can solve equations is by knowing that if you take two complex numbers, both of them have a real part, plus or minus, both of them have an imaginary part. If you state that they are equal, what you do is you take the real parts and you set them equal, and you could solve for a variable. You take the imaginary parts without showing the I, just the value that's imaginary, set them equal to one another and solve. So let's do two questions like that. Okay, so here on this side, what is real is 2x. I know that because it's not connected to an I. There's nothing else real here, so I put an equal sign to indicate, hey, I'm going to the other side. On this side, what's real, what does not have an I, is a -6. Go ahead and divide both sides by 2. -6 divided by 2 is -3. Now, if I want to solve for y, I go to this side and I was like, okay, so what's imaginary? You don't write the I. The I helps you to identify what's imaginary. On this side of the equation, the -3 is imaginary. Equals. On this side of the equation, what has the I? 4y. Now you can solve for y by dividing 4. So y equals -3/4. So I solved for x and y by using this statement. If you have two complex numbers with an equal in between them, you take the real parts, set them equal to one another and solve. Take the imaginary parts, set them equal to one another and solve. Let's do one more just to make sure we've got it, okay? -4x is real because it does not contain an I. Equals, on this side, 8 is real because it does not contain an I. To solve for x, go ahead and divide both sides by -4. +8 divided by -4 is a -2, and we're done. Now, if I'm looking for imaginary terms, this is imaginary and this is imaginary. Remember, a minus sign is always tagged to whatever's behind it. When you create your equation, though, you do not write the I. So it's +5 is imaginary equals -6y is imaginary. Go ahead and solve for y. I divide both sides by -6, so y is a -5/6. Okay, so that's a skill that we can do as long as you are comfortable with complex numbers. You can use complex numbers to solve equations. We can add, subtract, multiply complex numbers. All solutions, you need to make sure that your final solution, you have the real number plus or minus, then the imaginary number. So if I am adding two complex numbers, it's kind of the same thing as like combining like terms. The real numbers get added together. So here the real number is 1, here the real number is 3. 1 plus 3 is 4. Now you combine the imaginary numbers. You're adding them. So 1i plus a -7i, 1 plus a -7 would be -6i. Done. Add the real numbers together, add the imaginary numbers together in that order. Okay, now I'm subtracting. So I take the real number minus the real number minus the real number. 4 minus 8 is -4. Now I take the imaginary number minus the imaginary number. 3i minus a -6i. If you minus a negative, you're actually adding. So 3i plus 6i makes 9i. This is a complex number because I have a real part followed by an imaginary part. We can multiply. If you are multiplying, you take number times number and you count up how many i's you have. 4i times 2, well, 4 times 2 is 8. This has an I, this does not, so together it's 1. Plus, go here, multiply the numbers. 4 times 1/2, well, 1/2 of 4 is 2. I and I makes I squared. Now we're going to another one of our little rules. Anytime you have I squared, you need to replace it with the numerical value -1. So notice here I have I squared. So this is 8i plus 2, where I have I squared, that's a -1. If I multiply this out, I have 8i positive 2 times -1 is -2. I cannot leave my final answer like this because they reminded us a true complex number has the real part first. So the -2 needs to come before the positive 8i. This would be your final answer. You can multiply two complex numbers together. You're doing the FOIL method, okay? Just like we've done with other terms. If I take the first term times the first term, what I'm doing is I'm multiplying the two real numbers. 2 times 3 is 6. Outside, positive 2 times a -4i is -8i. Inside, positive I times 3 is positive 3i. Last, positive I times -4i is -4i squared. As soon as you see I squared, remember that needs to be replaced with a -1. So this is -4 times -1. Negative times a negative makes this a plus 4. So this is what I have. But now when I write my final answer, I need to combine like terms. Remember, the real number has to come first. 6 and 4 are real. I know that because they do not contain an I. 6 plus 4 is 10. The middle, -8i plus 3i is -5i. So we can actually do operations like adding, subtracting, distributing, multiplying with complex numbers. Let's look at the backside. We're going to continue practicing these skills. If you are adding the real number plus the real number, 2 plus 1 is 3. take the imaginary number plus the imaginary number, just like any variable. If you have a letter without a number in front, it's an unwritten one. So negative 3i plus 1i is negative 2i. You're done. If I am subtracting the real number minus the real number, 2 minus 4 is negative 2. The imaginary number minus the imaginary number. I'm minusing a negative, so that means that I'm actually adding. 3i plus 2i makes 5i. Real number comes before the imaginary. Here's a distributing problem. 10i times 5 makes 50i minus 10i times 2i. Well, 10 times 2 is 20. I times I makes I squared. Anytime you have I squared, you need to replace it with a negative 1. Negative 20 times negative 1 is positive 20. So these are the two terms you have. When you write your final answer, 20 has to come first because it's real, followed by your 50i because that's imaginary. Let's look at a couple more where we are foiling. Okay, so we're going to go ahead and multiply. 3 times 2 is 6. Outside, 3 times negative 5i, negative 15i. Inside, I times 2 is 2i. Last, this is an unwritten one. 1i times negative 5i is negative 5i squared. Again, as soon as you see I squared, replace it with negative 1. Negative 5 times negative 1 is positive 5. Combine like terms. Make sure that your real numbers go first. 6 plus 5 makes 11. Negative 15i plus 2i is negative 13i. Done. Okay, now here we are multiplying conjugates. The real numbers match. They're both a 3. The imaginary numbers match. They're both 2i. The signs in between are opposite. One's plus, one's minus. Check out what happens here. 3 times 3 is 9. Outside, 3 times a negative 2i is negative 6i. Inside, 2i times 3 is a positive 6i. Last, 2i times negative 2i is negative 4i squared. As soon as you see I squared, you need to replace it with a negative 1. This is a product, meaning you're multiplying. Negative 4 times negative 1 is a positive 4. So that's what negative 4i squared is. Now when I go to combine my like terms, 9 plus 4 is 13. Negative 6i, positive 6i cancels. When you multiply complex conjugates, all of the i's cancel and you end up with a real solution. Okay, and that is important as we continue through this section. Let's do one more. If you have, oh, this is supposed to be an I, I'm sorry. Okay, if I have 4 plus I to the power of 2, this means that I actually have 4 plus I 2 times. This exponent means that this group happens twice. Then you'd go ahead and multiply it. 4 times 4 is 16. 4 times I is 4i. I times 4 is 4i. I times I is I squared. Anytime you see I squared, you replace it with a negative 1. Combine your like terms. Make sure that the real numbers go first. 16 and a negative 1 makes 15. 4i and 4i makes 8i. Okay, so there's quite a few examples, 10, where you're either adding, subtracting, or multiplying. Complex number solutions come in pairs. Okay, so again, complex conjugates. So for example, you would have 2 plus or minus 3i. Okay, those are complex conjugate. Let's say I have square root of 5 plus or minus I square roots of 3. Complex conjugate. Okay, so when you have conjugates or complex numbers, they do come in pairs. What that means is you cannot have one without the other. As soon as you know one solution, you automatically know another solution. Okay, that's because I equals the square root of negative 1. Oh, okay. We're going to go ahead and keep moving on. Sorry, I have this. So anytime you have a complex number, it comes in a pair called a complex conjugate. Because I is equal to a square root of a negative 1, you cannot have I in the bottom of a fraction. Because remember, there's that rule that you can never have a square root on the bottom of a fraction. Because I is technically a square root, you also cannot have an I in the bottom of the fraction. So if you have a fraction with an I on the bottom, to cancel the imaginaries, you multiply both the top and the bottom by the conjugate of the denominator. The reason why it's the conjugate of the denominator is because you're trying to get rid of the I on the bottom. So if I look, I cannot have an I on the bottom. So I find the complex conjugate of the bottom. I keep the 1 the same, I keep the 2i the same, but I have to change the sign in between. So my plus becomes a minus. If you multiply something to the top, you also have to multiply it to the bottom. Now here I'm going to have to FOIL the top and the bottom. 3 times 1 is 3. 3 times negative 2i is negative 6i. 4i times 1 is 4i. 4i times negative 2 is negative 8i squared. Anytime you have I squared, you replace it with a negative 1. Negative 8 times negative 1 is positive 8. So the new numerator, combine your real terms. 3 plus 8 is 11. Combine your imaginary terms. Negative 6i plus 4i is negative 2i. Now we multiply the bottom. 1 times 1 is 1. 1 times negative 2i is negative 2i. 1 times 2i is 2i. Negative 2i and a positive 2i is negative 4i squared. The middle two terms are opposite, so they cancel. Negative 2i, positive 2i. Where you have I squared, that becomes a negative 1. Negative 4 times a negative 1 is a positive 4. So the denominator is 1 plus 4, which is 5. This is okay to have as a solution. You can have an I on the top. You just cannot have an I on the bottom because you can never have a square root on the bottom of a fraction, and I is technically a square root. Let's look at one more of those. If you have a quotient, okay, you have a fraction, and it has an I on the bottom, you have to figure out the conjugate of the bottom. I keep the real number the same. I keep the imaginary number the same. I change the sign in the middle, so now it's 1 plus 2i. I need to multiply that to both the top and bottom. Because both the top and bottom had two terms, what I need to do is FOIL the top and the bottom separately. So negative 2 times 1 is negative 2. Negative 2 times 2i is negative 4i. 5i times 1 is 5i. 5i times 2i is 10i squared. Anytime you have I squared, you replace it with a negative 1. Positive 10 times a negative 1 is a negative 10. Combine the real numbers. The real numbers must come first. Negative 2 and a negative 10 makes negative 12. Negative 4i plus 5i is just I. That's the new numerator. Now we find the denominator. 1 times 1 is 1. 1 times 2i is 2i. Negative 2i times 1 is negative 2i. Negative 2i times 2i is negative 4i squared. Anytime you have I squared, you change it to a negative 1. Negative 4 times a negative 1 is a positive 4. If I combine the real numbers, 1 plus 4 is 5. Positive 2i, negative 2i cancels. Here is your final solution. To end this section, we are just going to go ahead and do some simplifying. Now, this is similar to what I did right away at the beginning of the notes, reminding you some skills that we practiced back in Algebra 2, okay? If you have a negative underneath, first thing you need to do is take out the negative 1. By definition, square root of a negative 1 is I. 20 is not perfect, so I break it down. 20 is 2 times 10. 10 is 2 times 5. Anytime you can cross off 2, you can write it on the outside once. 5, I could not cross off, so that is still under. Now, this is a product. You multiply these two terms together. You're not allowed to change what's underneath the radical. So what you're multiplying are the values that are out front. If I take 2 times I, it's 2i, and it's connected to the square root of 5. Okay, here's the next one. I have a 2 out front, a negative underneath the radical, so you pull out a negative 1. That makes the 9 positive. I have a 2. The square root of negative 1, by definition, is I. The square root of 9 is 3. This is a product. 2 times 3 is 6, and it's connected to an I because it's an imaginary number. Last one, you guys, that's it. So I have a negative 3 out front. Negative underneath the radical, you pull out a negative 1. That way the 12 is now positive. This is negative 3. The square root of a negative 1 by definition is I. 12 is not perfect, so I go ahead and I break it down. I can break 12 down to 3 times 4. I can break 4 down into 2 times 2. I can cross off 2 2's. That allows me to write a 2. 3 cannot be crossed off. So now my solution is whatever I get when I multiply those together. Again, you cannot multiply what's underneath the radical, so I'm multiplying the numbers in the front. Negative 3 times I times 2. Well, negative 3 times 2 is a negative 6. I means it's imaginary. We have a square root of 3. That is section 4.5. Your assignment is a book assignment, so if you want to turn to page 300, I kind of skipped around a little bit, 1 to 5, then jumped to 9 to 14, check out number 23, then go ahead 26 and 27, 37 to 42, jump up 58 or 55 to 58. So it does look like a lot of questions. It's only 24 questions total. I promise you they go pretty darn fast. I hope you enjoyed learning about complex numbers, and I'll talk to you soon.